let's take a look at some problems that feature Charles' law. So we have our Charles' law equation indicated here. And the interesting thing about Charles' law, which is different from that of Boyle's law, is that it compares volume and temperature. It has a direct relationship, which means that as the volume increases, so does the temperature. And so what's also important to note is that I usually use units of liters for my volume. And for temperature, you absolutely must use Kelvin temperature to get the correct answer. So let's get started. In this first question, we're asked to calculate the decrease in temperature when 6 liters at 20 degrees Celsius is compressed to 4 liters. So first we're going to solve for one of our variables and then answer the question by calculating the amount of decrease. So let's go ahead and look at doing that, shall we? We have our volume, which our V1 in this case would be 6 liters. We also have our T1, which is going to be 20 degrees Celsius. That's going to be later be converted to Kelvin temperature. We now have our V2, which in this case is 4 liters. And we are trying to extract the value of T2. Now, if you notice anything, that T2 is located in the nominator position, and we are going to have to solve for that. However, what I tend to recommend is to position the variables such that all of those variables are located in the numerator position as opposed to some of them being located in the denominator position. So rearrangement would lead to this equation. V1 T2 is equal to the product of V2 T1. And then you can cross multiply or divide or whatever you see fit going from there. Now, I'm going to go ahead and go forward with converting this T1 value to Kelvin. That can be achieved by adding 273 roughly to equate to 293 Kelvin. So I have that value. I'm going to go ahead and plug in my V1, in this case 6 liters. Going to multiply that by my T2, which is unknown at the current moment, and set that equal to the product of 4 liters and 293 Kelvin. So, from there, divide both sides by 6 liters. And solve. This is canceled out, so our product is going to be equal to T2, of course, using our trusty calculator. We take 4, multiply that by 293, and we divide that by 6. That gives us a value of 195.3. However, if we're using 3 sig figs, I would go ahead and round that to 195 Kelvin. Now, that's not the answer to the question. That's just the answer to T2. And if you recall, it's saying calculate the decrease, which is basically the change in temperature from T1 to T2. Now, if you used and kept the values in Celsius, I could imagine that you would have gotten a kind of completely different answer. So we're going to, in this case, just subtract T1, which is 293, from our T2, which in this case is 195. And that will give us our delta T value, which is what they're trying to find. Delta meaning change, and T, change in temperature. So 293 minus 195 yields 98. So that is the decrease in temperature that is experienced. Remember, that's not the same thing as T2. T2 was this value. The answer that we're looking for is this one. Alright, let's go ahead and move to our next question. I'm going to fold the paper a little bit here to make space for myself. And once again, I'm folding incorrectly, but we'll go ahead and make do. Alright, so in this next question, we're looking at a gas that occupies 900 milliliters at a temperature of 27 degrees Celsius. What is the volume at 132 degrees Celsius? Now, it is very tempting to attempt to solve these problems using the temperatures in degrees Celsius. However, they must be solved using Kelvin, or you'll end up with perhaps an incorrect answer. Most likely an incorrect answer. So, let's look at this. I'm going to go ahead and write down V1, T1, V2, T2 as my variables given. I also want to list the ones that we have. And we're giving a volume of 900 milliliters, which I'll later convert to liters. We have our T1 value, which is 27 degrees Celsius, which I'm going to convert that to Kelvin. Our V2 is unknown, and our temperature, or T2 rather, is 132. And I want to take the time to point out a couple of things before we go forward for solving the problems. Before you go through anything, because volume and temperature share a direct relationship as it relates to Charles' law, you should see an increase in this V2 value, and I'll explain it. According to the law, it states that as this guy increases, which is 27 going to 132 degrees Celsius, we can surmise that V1 should increase from 900 milliliters to some value. So when we solve it, we're going to look at that relationship and see if that holds true as well. So let's go ahead and solve it. I'm going to convert this guy to liters. And you can convert to liters by dividing milliliters by 1,000. I'm going to next convert from 27 degrees Celsius to Kelvin, which will yield roughly let me correct myself, 300 Kelvin. I still don't know my V2 value, but that's going to be in liters, whatever it is. And we're going to add 273 to this 132 to yield a value of bear with me. 405 Kelvin. So now let's go ahead and plug these in and solve for V2, shall we? V1, actually let's back up. Let's recall that V1 T2 is equal to V2 T1. And so let's go ahead and solve this correctly. We'll go ahead and place our value of V1 in place. Then we'll go forth and calculate T2, which is 405 in this case. Then we'll go ahead and connect that to this V2 that we are not sure yet of, and we'll plug in our T1 value here. Divide both sides by 300K. And then use our trusty calculator to solve. 0.900 times 405 divided by 300 yields a value of 1.22, and that is in liters. Now, as we stated earlier, this should also increase according to the direct relationship shared in Charles' law, which states that as volume increases, temperature shares a direct relationship, which means it consequently increases. This temperature increased from 300 Kelvin to 405. This increased from 0.900 liters to 1.22 liters. And there you see how the comparison of Charles' law does in fact hold up when comparing the two. Now, if you look back when we were comparing them, we had 6 liters here. This decreased to 4 liters. That should have said that our 293 Kelvin of T1 should have decreased to a much lower value, which indeed did hold true, and it decreased to 195. And so, even if you're not sure of your answer when solving a Charles law based question, it helps to understand the relationship of volume and temperature being direct so that you can effectively solve them, and fact check yourself and make sure you are on the right track when solving these type of problems. So that should conclude our information on Charles' law.